Hello everyone, welcome to another interesting episode in The Art of Engineering Efficiency. In this episode, we will see what really shapes a software engineer's career in software tech industry. Before we dive into the details, let me share a small story. There was an young civil engineer graduated from a college and got placed in a well-reputed construction company. Soon after joining the company, he started getting his hands on day-to-day activities. Later, around 2 years, he started thinking he knows everything in the construction. With that idea in his mind, he approached many clients. Finally, one client approved his request. He got a project on his own. And next, immediately, he resigned to his job. He got all the inventories, resources, plans and everything to start a project, and he started. So when the project reached 60% of the construction phase, he found few cracks and leaks across the building. At the same time, there was a moderate storm hit the town, which actually shook the building. He got terrified and having no clue what to do there. He called his supervisor from the previous company. He asked help to have a quick inspection of his project. Next day, he told he will be coming there. This guy couldn't sleep properly over the night, thinking what could go wrong in the project. The next day, his supervisor came for an inspection of the project. He thoroughly inspected and shared the feedback and left from there. He literally shocked by reading the lines mentioned in the feedback. The building foundation is very weak because the core principles part of the construction were completely neglected, leading to a weak construction which doesn't last long. At that moment, many things flashed in his mind. He needs to reinvest a lot of time, effort and money from his own pocket. On top of that, he needs to answer the client the reason for the delay and the poor build quality. Let me stop this story here. And the key takeaway from this story, if we look at, is regardless whether we are in a field of construction or a software, the core principles lays the strong foundation to any project. Furthermore, it supports the scalability of the project, ensuring the quality and reliability in future phases. Now let's see what are the 4 important key phases in a software developer's career. First one is foundation phase, where a software developer or a programmer evolves and matures as a software engineer. Second one is improvement phase. Here the software engineer becomes individual contributor or self-reliant who needs less supervision to deliver the outcomes. Third one is exploring phase. Here the software engineer becomes senior and takes additional responsibilities like in the areas of architect, innovation and leading the technical teams. And fourth is influencing phase. In this phase, a software engineer is much more senior engineer who actually guide the teams, set the standards, bring in the latest technology trends and reshape the entire systems in the organization. In today's episode, we'll see what are the key essentials and principles are a part of foundation phase. So I have come up with 2 areas which are segregated to coding principles and non-coding principles. When we say coding principles or discipline, there are 3 major factors here that to be noted. First one is naming convention, second one is documentation, and third one is functional development approach. So what is naming convention? In a coding or a programming, naming convention promotes the readability of the code when we define or declare a class, a method or a variable. This not only promotes readable, additionally easy to maintain the code, and whoever is working on this code will have a better understanding when they look at proper naming convention in the code. The second one is documentation, which I would say is an extension to the naming convention, because when we follow naming convention, almost every class, a method or a variable will have a proper names. So we may not need an additional documentation to the properly named items. So when do we actually need a documentation? When a method or a function has a complex logic within which is a bit hard to understand by looking at the code, or the developers may need to invest an additional time to understand. For example, if we look at any e-commerce based application in a cart checkout, once we add all the items and when we proceed to checkout, in case if our total price exceeds 1000 rupees, there would be a coupon applied with a 5% discount on the total price. Similarly, when the price got increased to 3000 or 5000, the respective discount coupon may get applied based on the percentage. So this behavior is something we can relate as dynamic. This logic would be complex to handle in the code as well. For this kind of logics, which is dynamic in nature, a detailed documentation is always recommended, so that even a future developer who gets chance to work on any enhancements on this kind of logics will get better understanding by looking at the documentation. And the third one is functional development approach. Is moreover a streamlined approach to distribute our code across various classes and methods instead of putting an entire code of a feature in a single place. If we look at Lego blocks, a car built using Lego blocks, initially we need to build a car components like tires, engine and body of the car as a separate components. When we assemble all together, they become a car. That means in our terminology we can say it as a feature. So the same thing is applicable in our functional development approach as well. What do we achieve by doing this? When we follow the functional development approach, we write an independent and decoupled functions or methods which won't impact the application's state at any point, even if the application is running on concurrent threads. To add on, entire feature is 100% unit testable to meet all the use cases part of the requirements. This is very essential for a software engineer to make their code unit testable to meet all the requirements. And because our code is now decoupled and independent, when there is a new feature coming as part of enhancement, it is very easy to build on top of the existing code with minimal changes. So there our approach allows scalability. So now we meet all the four basic principles: naming convention, documentation, functional development approach, and unit testing and scalability. Now our code combinedly we call it as a reliable code or a reliable software feature. So next we'll see what are the key items which I am covering in non-coding discipline. First one is flowchart and analysis. The second one is defect fixing and RCA. And third one is a Jira Hygiene. So when I say structure our thoughts to flowcharts, we need to, whenever a task or a story is given to you, you should not directly jump and start coding. You need to come up with the initial analysis to put your thoughts on a paper or somewhere that you can show to others. Even as writing a pseudocode also helps. Or we can go with the flowcharts where we can explain pictorially to others. What do we get in return of this analysis phase? We'll put what are different conditions or use cases to meet the requirements. If there are any missed use cases as part of our thought process, we can highlight to the project team or the technical leads. We also need to get our flowchart or analysis get reviewed by peers or colleagues. Irrespective of their experience, it's always better to get it reviewed. You get diverse inputs from rest of your teams, and further you can proceed with the constructive feedback to see the positive results. So always don't hesitate to get a feedback from your peers. And next is defect fixing or debugging or finding the RCA. Very much important when it comes to a software engineer. There are many cases where a software developer tend to go with the quick fixes to release their application, and they open gate to they open gate to many new bugs in spite of fixing one. So to avoid this, one should dig deeper to understand code in a better way and find the right place, what is actually causing the issue, and provide a permanent fix in such a way that we won't be getting the issue in future. So always dig deeper. So RCA is not just finding the root cause, it is the curiosity that you develop to dive into the code, understand the project in a better way. On top of that, you own the responsibility to provide a solid fix which is unnoticed or went through many testing phases. So always pay attention while finding a root cause before fixing the defects. And the last one part of the non-coding discipline principle is Jira Hygiene. Often many developers tend to miss this point, but which is a professional way. Many people usually they only share their update in the stand-up or scrum meetings at the start of the day, and the rest of the day no one knows. Maybe the person who is sitting next to them would be knowing what they're actually doing, but no one else in the team would know about them. It's always good practice that update your status in the comment section of the ticket. If you're starting freshly analyzing a task, or you're started to work on the UI, or you're in integration phase or a testing phase, or if the development is completed and you have raised a PR and it is under review state, always, every small thing you can add as a simple comment in the ticket. What we get actually from this, there are many people who you may not be aware in the organization related to this project who are closely monitoring. So those people in the senior management may not ask your squad lead or you to update the status on a ticket, what you are working on a daily basis. Their purpose is to track the progress of a tickets during the development. So this improves the traceability and to monitor the progress of any task that anyone is working on. On top of that, in case if you have any blockers or challenges, if you tag them in the tickets, it will directly notify to the other person who needs to resolve them, or your scrum master or squad lead will take a look at them and try to collaborate with the other team members to resolve the issue. So this improves the team collaboration as well. And finally, this improves the professionalism in your work area, so that no one needs to call you or pull into some ad hoc calls to understand your status on a particular task. So that's all we have, the key essential topics as part of the foundation phase of a software engineer. In our next episode, we'll be covering the key factors which impacts the improvement phase of a software engineer. Till then, stay tuned and thanks for watching.